So let's keep going with our problems from Halliday and Resnick, chapter 28, problem number 5. This is a version. I mean, a little bit complicated. Okay, I can't say that. It's just a little bit more difficult than problem number 3 from chapter 28. But the main idea is the same, guys. So if you are struggling with this one here, go to problem number 3, try to do it, and try to apply the same mindset here, because what we're going to need to use here is the formula that correlates a charge, velocity, force, and magnet field. So the one that I'm talking about is magnet field force. It's going to be equals to the charge of the particle, velocity vector, cross product with the magnet field. This is the formula that you need to use when you are dealing with charge, velocities, and magnet field. Cool? Okay, so let's go. Well, we have here a magnet field and a velocity, magnet vector, right, and the velocity vector here. And they give us the force vector here, and it is what? In k, right? So, and they are asking us to calculate bx. Okay, so let's do it. What are the things that we need to remember before we start? So we are dealing with the charge here. It's going to be an electron, right? So if you are doing an electron, so the charge will be 1.602 times 10 minus 19 coulombs. Okay. What else do I need to remember? Well, let's keep going. Let's see what's going to be what's what's going to show up here. So let's go. So we have this formula, and pretty basic. It's like, okay, but I know this guy, the force, I know the charge, but I think I don't need the whole matrix for this guy here. And you are right. Take a look. If you do the matrix here just for the velocity and the field, if you remember, we did this for problem number 3, and what we had was like, okay, velocity x, velocity y, velocity z, right? And here will be bx, by, and bz, right? But we know, guys, we know that our force will be only in direction k. So the only one that we need to be concerned with are these guys here. So it's going to be this one times this one here, and this one times this one here, but it's going to be negative, right? So the total vector that we're going to need here truly is going to be vx, by minus vy, bx. Okay, and it's going to be in k direction. So basically this is what we have here, but remember this guy here is the magnitude of this vector, right? Okay, so let's go. Let's keep going here. So now let's plug this guy here into our formula, okay, because this is going to be the result for this one. Okay, so let's go. We have the magnet force here, so it's going to be the charge, and going to be Vx, By minus Vy, and Bx. Okay, we know what is the answer here because the force, but we need to plug it in what we need here. So By, take a look in By here. Our By, it's equal to what, guys? 3 times Bx. So let's plug this thing here on our force equation. So it's going to be charge. Listen, I'm not plugging in any number so far. So Vx, let's put a bracket here. So Vx is going to be 3 times 0 bx, because by is going to be 3 times bx minus vy and bx. And the problem is asking us, what is bx? So now is the time for us to do something here that can help us a lot before we start to plug it in like crazy, the numbers here. So can you see that we have bx here and we have bx here? So let's make our life easy. So it's going to be the charge, okay? And then we're going to have, okay, bx, and it will be 3 times Vx minus Vy. Do you agree that we're going to have the same thing? Awesome. So now I just need to figure out who is this guy. And to do that, everybody here is multiplying. So that allows me to do something like this. Take a look. F, V, the vector here, or the magnitude, and its charge here times 3.0 Vx minus Vy. Okay, so look, we have here Fb, the magnitude, 6.4 times 10 minus 19. We have the magnitude here, so we can plug it just the magnitude, okay? Because we're gonna have here just a component here, so we can do only the magnitude. So take a look now. Vx, we have Vx 2.0. Vy, we have Vy 4.0. So the magnitude of Bx will be what? So I have to fix this stuff here first because it was horrible. So it's gonna be like that one gets worse. So I want to do the best one here. So take a look. Okay, it's better. So now our force will be just the magnitude 6.4 times 10 minus 19 newtons. The charge here will be what? Will be negative 1.602 times 10 minus 19 coulomb, and times what, guys? 3 times Vx. But who is Vx? 2. So it's going to be 6.0 minus Vy. Who is Vy? Is this guy here. So it's 4.0. Okay, and everything here going to be meters per second. Okay, so Bx will be what? I just need to subtract this guy here, will be 2, multiplying here, so it's going to be negative, approximately negative 2.0 Teslas, and it's going to be negative. So it's going to be the negative directions. Okay, so it's going to be, I mean, the magnitude of the Bx will be minus 2.0 Teslas. So if you notice, we use the same mindset that we used to solve problem number 3. It's the same mindset. You just need to remember that, okay, I have the force already. So I just need to calculate Bx. It's just that, guys. It's simple. And I really believe that you guys can do it. Okay? See you later.